Mass and energy balance for biosystem. Module 8 Conservation of energy. Segment 2 Calculation of enthalpy in reactive process is Millie from School of Life Sciences and Technology, Institute Technology, Bandung. In the previous segment, we already discussed about the open, steady-state system, no and with potential or kinetic energy change. And in this segment, we will more discuss about the calculation of enthalpy in reactive process. During chemical reaction, rearranging the bonds between the atoms of reactants and product causes change in the internal energy of a system. And in reaction, energy is required to break the existing bond of the reactants, and energy is released during bond formation to create the products. The difference between the final and initial energy states of the products and reactant is known as the heat of reaction. In more detail, the heat of reaction or enthalpy of reaction is the enthalpy change for a single process reacting at a specific constant temperature and pressure, in which stoichiometric quantities of reactants react completely to form products. And the change in enthalpy for a reacting system is equal to the difference in the enthalpy of the products and the reactant. And the formulation can be seen in this following equation, where the N is the number of moles actually involved in or produced by the reaction, and Hn is the specific enthalpy of a species, and the subscript P is for product, and the subscript R is for reactant. Chemical reaction can be classified as either endothermic or exothermic. An endothermic process requires more energy to break the bonds of the reactants than is released when the bonds of the product are formed. It can be seen in the figure A. But for the exothermic reaction, more energy is released when the bonds of products are formed than is required to break the bonds of the reactant, which is shown in the figure B. For example, for the endothermic process is photosynthesis, and for the exothermic process is glycolysis. When calculating the standard heat of reaction, the phase of reactants and product must be known. A liquid is denoted with L, solid with S, gas with G, and crystal with C. And for example, if we consider the balanced liquid or L phase reaction, so the equation can be written as the following equation, and the heat of reaction in the liquid phase for the balanced equation can be written as the following equation. The standard heat of reaction can be calculated also using the heat of formation or the heat of combustion. The standard heat of formation of a compound is the specific enthalpy change associated with the formation of 1 mole of the compound at a reference temperature and pressure, usually at 25 degrees Celsius and 1 atm. For example, here is the formation of urea, and the standard heats of formation of compound carbon, hydrogen, nitrogen, and oxygen are 0. And the standard heat of formation for the urea and hence of the formation of reaction is negative, which is the reaction is exothermic. Heat of reaction calculation at non-standard condition. Biological reactions often do not take place at standard condition. Instead, reactions often occur at or near 37 degrees Celsius. Recall the change in the specific enthalpy in a system is the sum of all the steps in hypothetical path, so the equation can be written as follows, where the k is the number of steps in the hypothetical path. Each step along the path should be a chemical reaction at standard temperature and pressure, or a change in pressure, temperature, or phase. Consider again the following reaction between compound A and B to form product P and Q, and the equation of that reaction can be seen in the following equation. Now we assume that this reaction occurs at non-standard temperature T. The heat of reaction at temperature T is delta HRT, can be calculated using the hypothetical reaction pathway as shown in figure. So the first step on the hypothetical path is to either warm or cool the reactant from T degrees Celsius to 25 degrees Celsius. And the second path is the reaction at 25 degrees Celsius, at which the standard heat of reaction, or delta HR, can be calculated from either heats of formation or heats of combustion data. And then finally, the third step is to cool or warm the product and any excess reactants from 25 degrees Celsius back to the T degrees Celsius. And the enthalpy change for a given amount of material at a non-standard T is calculated from the part of the hypothetical path, and the equation can be seen in this following equation. A hypothetical path must be constructed for each reaction that occurs at non-standard temperature or pressure or both. And to account for temperature change, heat capacities are required. So for the calculation of heat capacity can be seen in the following equation, where the Ms is the mass of species S and S is the moles of species S. Cpt is the heat capacity that may be a function of temperature. T1 is the temperature at which the process begins, and T2 is the temperature at which the process ends. In the next segment, we will discuss about the open system with reaction. Until then, I'm Lily from Institute Technology Bandung.